Hello, this is Mr. Brooks, and welcome to Lesson 4.2, Triangle Congruence by SSS and SAS. What you'll learn in this lesson is we're going to prove two triangles congruent using SSS and SAS postulates. Our first postulate in Lesson 4.2 is the side-side-side postulate, which states if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. We will simply refer to this postulate as SSS. Now if we look at example 1 and we're trying to prove that triangle ABD is congruent to triangle CBD, they've given two pair of sides to be congruent. How are we going to get the last pair of sides congruent if we're trying to prove this using SSS? We would simply say BD is congruent to itself by reflexive property, because as you remember, anything is congruent to itself by reflexive property. Okay, now let's look at quick check number 2. Alright, we're trying to prove two triangles are congruent. Trying to prove triangle FGH is congruent to triangle JKH. Well, we're given two pair of sides are congruent, and we're given H is the midpoint of segment GK. Try to come up, please pause the video while you try to come up with step 2. Since H is the midpoint of segment GK, you can say HG is congruent to segment HK. But why can you say that? The reason is definition of midpoint. Now, for the final step, you can say your triangles are congruent. Triangle, if I call it triangle HGF, then I would have to call the second triangle HKJ. Why are they congruent? By side, side, side. Our next postulate in this lesson is the side angle side postulate, which states if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. First, I want to make sure you completely understand what we mean by included. If we're talking about segment XY and segment XZ, see if you can name the included angle between the two segments. The included angle would be angle X. It is basically the angle that makes up the two sides that we're talking about. Now let's look at the blue triangle, triangle MLP, and see if we're talking about angle L and angle P, what would be the included side between angle L and angle P? Hopefully you would say it would be segment LP. It's the segment that makes up those two angles, the side in between those two angles. Now let's look at example 2 and see if we can figure out how to get these two triangles congruent by SAS. Well, it's given that RS is congruent to TK. We would also need to know KS is congruent to itself by reflexive. Anything's congruent to itself by reflexive. And we would need to know the included angles. In other words, angle RSK has to be congruent to angle TKS. This angle right here would have to be congruent to this angle right here for these two triangles to be congruent by SAS. Now let's see if we can do quick check number 2. What additional information would we need to prove these two triangles congruent? Triangle ABC and triangle CDA. Well, we know that DC is congruent to AB because they both have 7s on them. AC is congruent to itself by reflexive. So we need the included angles to be congruent. Angle ACD would have to be, which is this angle right here, would have to be congruent to what angle? Hopefully you're going to say angle CAB. This angle would be the included angle between the two marked sides. If you knew those two angles are congruent, then you can say triangles are congruent by SAS. Now let's look at example 3 and see if we can prove these two triangles congruent. Well, we know that segment RE is congruent to segment CA. They both have one tick mark on them. That's given. And segment RD is congruent to segment CT. They both have two tick marks. And we know that angle R is congruent to angle T. Can we prove these two triangles congruent? The answer is no, we cannot. On the triangle RED, red, we have side angle side. But on triangle CAT, we have side angle. It is not the included angle. C would have to be congruent to R for these two triangles to be congruent by SAS. Now let's look at quick check number 3 and see if we can get these two triangles congruent. Again, we can say that angle ABE is congruent to angle DBC. These two angles are congruent. Hopefully you'll know that that's vertical angle theorem. And then the one on the right, we have side angle side, but on the triangle on the left, again we have side angle. So those triangles are not going to be congruent.